Hey guys, it's Miss Dockan. Today I wanted to talk a little bit about ways to represent numbers and different forms that you might see on the assignment that came home today or on different questions in the future, and how we actually represent the numbers that way. So standard form of a number is just the digits, okay? And just digits uses each individual number 0 through 9 to represent the larger number. Word form uses words. It's the one that's probably the easiest to remember because it's got it in the names. It uses the words. It is spelled out. And our kids do have all the number words spelled out in our classroom as well as in their red folder. In the very middle of it, their working folder has all of their number words for them. Expanded form shows the values of all the numbers. Or, excuse me, all of the digits. And I'm going to show some examples in a minute, so if you're like, I'm not sure, no worries, I gotcha. Base 10 blocks, if you watched my video on base 10 blocks, you'll know that these are using the physical base 10 blocks or drawings of it. And I'm going to put as a picture because sometimes you'll hear it referred to, especially when they get into 3rd grade, as pictorial representation. And so drawing them and having that picture there is what they're looking for there. And then if it says decompose in a different way, they still want to use base 10 blocks, but we want to see it decomposed or broken apart in a way different than just showing us the number of 10s and 1s like we normally do with base 10 blocks, but the value still has to be the same. So again, I'm going to show you that in just a second to show a different way. With the same value. So just some different forms, like I said. We've got standard form, just our digits. Word form uses the words, they're actually spelled out. Expanded form is going to show the value of each of the digits added together. It's going to have a plus sign. It's going to look like an equation. Base 10 blocks uses the actual base 10 blocks as a picture form, which is why it might be called pictorial representation. And then decompose it in a different way just means use your base 10 blocks, but show it a different way than you normally would with the regular base 10 blocks. But it needs to have that same value. So let me give you some examples. I have a board ready to go with all 5 of the ways. And what I'm going to do is a couple of examples. I'm going to start with just a 2-digit number with 5 and 8, so 58. Standard form is like we see it most of the time with just our digits, so that would be 58. Word form is actually spelling each of the words out. And I'm trying not to erase what's on the bottom as I write up here. 58. Expanded form, again, shows the values of each digit. So you start with the largest placed value, which is the 10s in this number. And I ask the kids, well, what is the value? What is it worth? And they'll tell me it's worth 50. 5 groups of 10, so 50. Plus, and then you go to the next place value. Well, our next place value is the 1s. It has an 8. It's worth 8 1s, or 8. So 50 plus 8. Then we're going to draw it using our base 10 blocks. So again, I'm going to start with my largest place value, which is the 10s place. I need 5 groups of 10. 10, 20, 30, 40, 50. It's important to remember that we don't cross these like tally marks. These are just being used as lines. Then I need to go to my 1s place. 1, 2, 3, 4, 5, 6, 7, 8. And just like I said in my base 10 block video, I want to make sure that I am drawing my 1s and my 10s that they look like a tens frame. 5 on the top, up to 5 on the bottom. Now, decomposing another way. I want to use my base 10 blocks again, and it still has to be the value of 58, but I want it to look differently. This is where we have taught our students, our kiddos, that it might look different but be the same value, such as if I had a $20 bill or 2 tens, still 20 bucks, or $21 bills, still 20 bucks. So the first thing we'll always show them is just to take one group of 10 away and break it or decompose it down into 10 ones. So instead of 5 groups of 10, I would do 4, so 40, and then make sure I have a group of 10, 50, and then add 8 more. And again, I want to make sure they're 5 and 5, and then I leave a gap so that I can see each group of 10 individually. Makes it quick to check it for both students and for me, and then when we start adding and subtracting numbers, we're able to use our base 10 blocks efficiently and effectively, and it's not messy. So that is something I'm working with the kids on. So those are all 5 ways of representing a number for the exact same number.